generally it was highlighted with the only the end generator only. Once if you are supposed to represent our cone, it should be highlighted for the end generators only. Okay. The points are, this was A dash, this is B dash of H dash, so this is C dash of G dash, this is D dash, in bracket it is F dash, it is E dash, this is O1 dash, this is O2 dash. Height of the solid is given, which is 70. Cut by the section plane and perpendicular to VP and inclined 35 degrees to HP and passing through the midpoint of the axis. So let us see, the midpoint of the axis is going to be somewhere at here, and it is passing through the inclined in this pattern, which is 30 degrees. So which are going to be thicken at ends. So this was represented by VT. Okay. So now mark the intersection points. So let us see. Always start from the extreme left. So this was my 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. So why? Because all the generators I am supposed to give the numbering 1, 2, 3, 4, 5 and 6, 7, 8 are the F, G, H are hidden edges. So 6, 7, 8 points are going to be for those. Okay. What was the retained portion? So this was the retained portion. Retained portion are only highlighted with the, so the portion between observer and cutting plane was removed. Okay. So generally I just want to highlight only the end. So let us place the points in their particular position. One point is going to be in between OA, so this becomes your 1. Two, okay, so 1, and again this becomes your 2, somewhere at 2. 3 point is going 3, this becomes your 8. 3 and 7, next 6, 4, and it is 5. Now what happened to 3 and 7? It coincide with the edge. So what you just had to do, you just to project the points to the true slant edge. What we done in the previous class, we just project the points to the true slant. This becomes my 3, 7. Project the point to the respective position and somewhere at here. This becomes some K. If you draw to here, and if you just draw to here, this becomes your 7. This becomes your 3. Now join all the points. Okay. So if you join all the points, you will obtain like this. It becomes 6, 7. Okay. Now mark with the section hatching. So what we did in a section of solid as in the previous class, I just drew this. A cone is going to be taken and it is cut by the section plane such that the axis is going to be inclined 30 degrees to HP. This was the retained portion. So this was becomes your front view only. This becomes front view. So this is sectional. Why? Because 1, 2, 3, 4, 5 and ABCD is existed. So this was also highlighted and this was also highlighted. Okay. Now let us see. This was the thing which we already know in the section of solid. But what we just had to do means we just had to do now. Let us see. Development of the retained portion. Let us consider this was the part P which is retained. So what is the formula for cone? 360 degrees into small r by capital L. So what is L? R is nothing but the radius. So radius is given as radius is equal to 25. L is nothing but length of true slantage. So what is the true slantage here? Either OE or OA. So that means which is nothing but O dash, E dash or O dash, A dash. You just take it, okay, and you just measure and you just calculate it. So theta is equal to 360 degrees into, so this is 25 by, let us measure true slantage. So which is going to be similar as obtained as some 75. So once you obtain your theta is equal to some 120 degrees, approximately 120. Okay. Now first of all, you just draw a line of true slantage. Okay. Draw a line of true slantage. So O dash, I just consider this was A dash. So draw an arc and you just close this sector such that theta is equal to 120 degrees. Now how can we divide this 120 degrees into 8 number of equal divisions? We already know how can we divide by angular bisector method. Okay, so this is also A and this is also A. Okay. And mark the points. So this is B, C, D, E, F, G, H, and again E. Angular bisector method, you know that. So take any convenient radius, draw two arcs. With these two as centers, you just obtain bisector. Now these two are going to be centers, and you just obtain the center like that. Angular bisector, which we already done in the previous classes. Now project the points to the true slantage. So what are the points which are on true slantage? 1 and 5. So remaining points also had to be projected to the true slantage. So I just project the points also to the true slantage. So this becomes your 2 comma 8 and this becomes your 4 comma 6. You just take the points and take the radius from the apex. Okay, let us see now. So one point which is already in the true slantage. So directly take O1. So this becomes your 1. Similarly, this becomes your 1. Next 2.2 and 8, which is on OB and OH. This is 2. This is 8. Next 3 comma 7. O3 comma 7, which is obtained on true slantage, is to be taken as radius from apex. So 3 is going to be on OC. 3 and 7 is going to be on OG. 7. Next 4 comma 6. So 4 comma 6 on OD and F. So this becomes your 4. So this becomes your 6. And this becomes your 5. 5 is on OE directly. Now join all the points. Okay. So here it was the cone which is of having the base circle of a circular shape, and there are no slant edges here, only two end generators. Those end generators are only highlighted like this. Okay, this was only highlighted. So this was your part P. So these edges are not to be highlighted. Students, 2B, 3C. Why? Because these are only generators. For cone, we just highlight only the end generators. That is 1A and here also 1A. So that was to be highlighted. Students, is it clear? Okay, students, we just stop our session at here. So tomorrow class we will see another 3 or 4 problems in these developments of surfaces, and we just close the development of surfaces tomorrow. Okay. So meanwhile, all of you just go through the textbook and see the problems. Housing. Okay. So take your true standard length what you have appeared.